Okay, so we're going to take a look at parallel line angle relationships. Just to get us started with parallel lines, we have the following. Parallel lines are two lines that never cross. So for example, if I was looking at this figure right here, lines L and lines N would be parallel. There's a constant space between those two lines. As a little reminder on our figure, remember the symbol that we would draw to recognize parallel would be some sort of pair of triangles, something along these lines. For L and N, we would say that L is parallel to N. That's our shorthand notation for parallel. Okay? And we're also going to add an extra line. Any line that crosses parallel lines is referred to as a transversal. So in this figure we have transversal, a line that crosses parallel lines, which I have called line T. All of our angle line relationships that we're talking about today are caused by this figure right here. You have a pair of parallel lines, and you have an additional line, or transversal, that is crossing those lines. Okay? And from that we're going to have four angle relationships that we can identify. So, first up, I've just numbered my angles 1, 2, 3, 4, 5, 6, 7, 8 so we can keep track of which ones are which. We have angles that are called corresponding. For corresponding angles, what I want you to imagine is taking this group of four angles and sliding them on down. And hopefully you recognize that angle 1 looks like it matches up pretty much right up with angle 5. Similarly, angle 2 looks like it matches up right with angle 6, right? And so on and so forth. 3 would match with 7 and 4 would match with 8. So I can put the following pairs. I know that angle 1 and angle 5 are corresponding angles. I know that angle 2 and angle 6 are corresponding angles. Okay. Just finishing down my list, I've got angle 3 and angle 7. So angle 3 and angle 7. And finally 4 and 8. Angle 4 and 8. All of those pairs would be considered corresponding angles. Now corresponding angles also have a special property which you may be guessing. It looks like they're the same, and they are, and so we're able to write the following theorem. If lines are parallel, then corresponding angles are congruent. Okay? Now I want you to think about this for a moment. When I named those pairs, any figure that looks like this will have those pairs. So 1 and 5 would be considered corresponding. But the moment I make these lines parallel, now I'm able to say that they are congruent. Okay? So to clarify what I mean, I could have this figure right here. Very clearly these two lines are not parallel. I could still say angle 1 and angle 5 are corresponding though, but I would not be able to say they're congruent. Clearly they're not in this picture, and unless I knew these lines were parallel, I can't assume that they are. So you might have corresponding angles, but unless you know the lines are parallel, you can't yet say they are congruent. Okay? Now in addition to corresponding, we have a few other angle relationships. So let's take a look at the following. I could have what's called alternate interior angles. And here's what I want you to think about. Alternate, opposite sides of the transversal. Interior, inside the parallel lines. So if I start with angle 4, which is inside my parallel lines, and I need to get on the opposite side of the transversal, I'm going to move over here to angle 6. So I would have angle 4 and angle 6. Right? And then I have another pair of alternate interior angles. I could go angle 3 and angle 5. Again, inside the parallel lines, opposite sides of the transversal. And like before, I can write a similar theorem. If you look at these pairs, it looks like obtuse, obtuse, acute, acute. It looks like they should match up, and they do. I can say that if lines are parallel, then corresponding angles are congruent. Right? So alternate interior, opposite sides of the transversal, that's the alternate part. Interior, inside the parallel lines. Moving right along, I can go on to my next one. Now I have alternate exterior angles, which you can probably start to make a guess as to what you think is going to happen. I'm still on opposite sides of the transversal, but now I'm looking outside my parallel lines. I am exterior to my parallel lines. So I've got angle 1 and angle 7. That would be one pair. And my other pair is going to be angle 2 and angle 8. Again, they are outside my parallel lines, exterior, and they are on alternate sides of my transversal. Right? And as you might have guessed, I just realized I made a mistake. So this one was not corresponding. That should have been alternate interior. I'm this far along, so I'm not going to redo the whole thing. Let's just roll with it. Mistakes happen. They're welcome here. So, if I continue, if lines are parallel, then alternate, I'm paying attention now, exterior, I got a room, exterior angles are congruent. Okay? So you can see there's a lot of similarity of what's going on. Now I have one more pair that I want to look at. Consecutive interior angles. Some books, I believe ours does from time to time, refers to them as same side interior. Originally they were known as consecutive interior, so I'm going to tend to use that word just out of habit for myself. But if you ever see same side interior, don't be surprised. They mean the same thing. So let's think about what it's saying now. Consecutive is a fancy word of saying next to, right? Interior, inside the parallel lines. So I need a pair of angles that are inside the parallel lines and next to each other. Boom. Same side interior, same side as the transversal, inside the parallel lines. So I would have, for example, angle 4 and angle 5, or angle 3 and angle 6. Okay? And here's where it gets a little interesting. We knew that 4 and 6 were congruent. 4 and 5 clearly aren't. I've got an acute angle and I have an obtuse angle, so what's going on? Well, we did a little playing around with class, so if you weren't there you might want to check it out, but I can say the following. If lines are parallel, I'm almost out of space, but I think I can fit it. If lines are parallel, consecutive interior angles are supplementary. They're going to add to 180 degrees. And you might be able to picture it right away. Angles 1 and angle 4, those would be supplementary, right? They form a straight line. And because of corresponding angles, we know that angle 1 and angle 5 have to be equal. Well, if this pair is supplementary, and 1 and 5 are equal, well then that pair must be supplementary. And we'll take a look at that in class. So again, corresponding angles, imagine just coming straight down. Alternate interior, imagine opposite sides of the transversal inside the parallel lines. Alternate exterior, outside the parallel lines, opposite sides of the transversal. Consecutive interior, inside the parallel lines, same side as the transversal. First three are all congruent angle relationships, and the last one is supplementary.